So in this video, I wanted to go over a problem for involving hypothesis testing for two dependent means. Before we look at that, or before we go through the problem, let's look at what the claim, the null, and the alternative would look like. So these statements, the claim, the null, and the alternative, contains this symbol, which is mu sub d, which is the population mean difference, the population mean for the differences. The claim is going to vary, but it should always be in this format, mu sub d compared to 0. The null always is always mu sub d equals to 0, and the alternative would always depend on what the claim is. So if you guys recall, the alternative, h sub 1, is the opposite of the claim if the claim contains a not equal sign, a less than sign, or a greater than sign. Otherwise, it's the opposite. All right, so let's go through the problem. So the problem reads, listed below are ages of actresses and actors at the time they won an award for the categories of Best Actress and Best Actor. Use the sample data to test for a difference between the ages of actresses and actors when they win the award. Use a 0.10 significance level. All right, so let's kind of highlight the important things here. So we're testing for a difference between the ages. The significance level is 0.10 significance level. These are match pairs. So in this case, the year that this actress won, she was 17. The same year the actor who won was 47. And likewise for this, the year that the actress won for Best Actress, she was 27. And that same year, the gentleman was 40, and so on, right? It creates a match pairs because these were the same year that the actors or actress won um, for Best Actress or Actors award. All right. So in this case, because we're testing for a difference, our claim involves mu sub d, the population mean for the differences is not equal to 0. So to say that there is a difference, another way to say that would be that the mean difference is not equal to 0. Otherwise, if it was equal to 0, the values would be the same. The difference would be um, equal, right? The averages of the difference would be equal, right? The null is always mu sub d is equal to 0. The alternative in this case, because the claim contains a not equal sign, it's the same as the claim. So mu sub d is not equal to 0. So the answer would be choice A. So here, we're going to use the p-value method to test the claim. So since there's a match between, the first sample is dependent with the second sample, and there's matching pairs, with this scenario, we're going to combine the two lists we're going to create the difference list. So we're going to combine the two lists to create the difference list, and we're going to treat it like one sample. We're going to treat this as one sample using the difference list. Okay, so using your TI-84, we're going to go to stat, edit, we're going to input this first list into L1 and this second list, the actors' ages, into L2. And I already did that here. So these are the actress's age and these are the actor's age. With L3, I'm going to create the difference list. So to do that, I'm going to go up, highlight L3, press enter, and I'm going to do L1 minus L2. So second 1 minus second 2. And that creates my difference list. So for example, this negative 30 is the difference between 17 and 47. And negative 13 is 27 minus 40, and so on, right? So once we have our difference list, we're going to run the test on this list. And we're going to treat it like it's a one sample for mean, right, for a mean. So if you guys recall, the function that we're going to use for that is the t-test, because we don't know the population standard deviation, right? So we're going to use a t-test for that. So press enter, We're not given stats, we're given a list of data, right? And that, so go to data, press enter. Mu sub 0 is the value that's to the right, on the right of our claim and our statements here. The list is the difference list, so in that case, that's L3, right? That's the difference list is in L3, so second 3. Frequency, we're just going to leave it as 1. It defaults to 1, so we're going to leave it as that. This is the alternative, so the alternative is not equal. And then we're going to press calculate, and there it is. So this is the test statistic. This is the p-value. So let's write those down. So the test statistic rounded to 2 decimal places is negative 2.70, and the p-value rounded to 3 decimal places is 0.054. All right, so once we have our p-value, for the p-value test, we're going to compare it with alpha. So p-value compared to alpha. P-value is 0.054. Alpha was, 0.10. So p-value is less than alpha. And if you guys remember, when the p-value is low, the null must go, right? So in this case, we reject the null hypothesis. All right. So hopefully that makes sense. Again, as always, if you guys have any questions, let me know.